For decades, military planners operated on a brutally simple logic. If you bury a weapon deep enough beneath solid rock, no aircraft in the sky can touch it. That was the calculation. But in 2025, the United States struck targets deeper than thought possible, collapsing that assumption entirely. This strategy has been the centerpiece of Iranian military thinking for a generation. Without the most advanced air force or missile defense systems in the world, they turned physics into a shield and geography into armor. The math was straightforward. Dig a hole deep enough, and it doesn't matter what the enemy is flying. This philosophy shaped absolutely everything they built. They constructed sprawling, hollowed-out mountain complexes, entire underground cities packed with drones, rockets, and command centers, all connected by tunnels. The perimeter fences on these sites span massive, isolated mountain ranges, putting miles of barren rock between the facilities and the outside world. The United States eventually spent years engineering a specific weapon to break those exact mountains. But what military planners discovered on the ground was far more complicated. Cracking the rock was possible. Stopping the Iranian war machine operating beneath it was a completely different problem. The specific problem driving U.S. weapons development was one heavily fortified site in Iran, the Fordo Enrichment Facility. The Pentagon spent a decade and a half engineering a bomb around this single target. The result weighs roughly 30,000 pounds. It requires an exclusive delivery system, carried only by the B-2 Spirit stealth bomber shown here. This 2D cross-section illustrates how the GBU-57 functions. Instead of a surface blast, it uses kinetic energy to drive down through rock. The 6,000-pound warhead's delayed fuse triggers only after punching through 200 feet to reach the target chamber. In June 2025, during Operation Midnight Hammer, stealth bombers dropped 14 of these bunker busters on Fordo and Natanz simultaneously. Iranian authorities confirmed the sites were hit. The deepest known nuclear facilities had been successfully struck from the air. The physical engineering worked exactly as designed. The deepest facilities were breached. But relying solely on explosive kinetic power exposed a fatal flaw in the broader strategy, a flaw that became obvious as the conflict expanded. South of Isfahan sits the Sofi Mountain Missile Complex. As the war escalated, this became one of the most heavily targeted strategic locations. Stealth bombers and B-52s hit the complex repeatedly, striking it roughly 20 separate times. By every visible metric, the mountain took devastating damage. Satellite reporting verified that 77% of the complex's entrances had been successfully struck and collapsed. Yet, despite nearly 20 strikes and collapsed entrances, residents nearby reported watching missiles launch from that exact same mountain the very next morning, over and over again. This photo inside an Iranian tunnel reveals why. The entrances are completely separated from the storage chambers by hundreds of meters of corridors. Destroying the opening on the surface does nothing to compromise the actual equipment stored deeper inside. This created an absurd economic imbalance. The United States was deploying expensive, heavy precision munitions that cost millions of dollars per drop. In response, Iran simply rented local construction equipment. Within days, cheap bulldozers and dump trucks cleared the debris and repaved the access roads. It turns out sprawling, redundant tunnel networks absorb precision firepower incredibly well. If a country is willing to keep pouring concrete and sending in workers, heavy bombing campaigns degrade into temporary logistical delays, not permanent defeats. But the math changes entirely depending on the target. In early June 2026, during an active combat rescue operation for an American pilot, forces needed to neutralize an underground headquarters near the Iranian capital. A 4-star commander authorized the heaviest bunker busters for this specific location, prioritizing an urgent, concentrated drop on one confirmed room. The strike destroyed the headquarters outright. There were no secondary tunnels to use and no bulldozers repairing the entrances the next morning. At Sofi Mountain on the left, planners faced an interconnected web of tunnels. They had to guess which entrances led to high-value equipment. But near the capital, on the right, the intelligence picture was flawless. They had exact coordinates for one specific room. This reveals the underlying rule of the subterranean war. Mass quantity and cheap repairs beat precision when a target is spread across a massive network. But when intelligence successfully pinpoints one specific room, precise firepower beats infinite depth. Iranian planners internalized this exact lesson. They recognized their distributed networks could survive relentless bombing, but also understood the extreme vulnerability of their high-value assets if precise intelligence ever located them. They did not wait for the bombing to pause. Assuming their current depths would eventually be compromised, they simply chose to dig deeper than they ever had before. This image shows rows of centrifuges, the exact type of highly sensitive nuclear equipment Iran actively seeks to protect. Recent satellite imagery indicates they began quietly transferring thousands of these machines into a new facility known as Pickaxe Mountain, carving out space more than 300 feet below solid bedrock. At more than 300 feet down, that site is deeper than Fordo. More importantly, it sits firmly below the known, verified reach of any conventional weapon currently in the United States arsenal. This dynamic sets the baseline for modern conflict. Adversaries have moved past reinforcing concrete or air defenses, choosing instead to outdig the current reach of conventional munitions. Every military watching this conflict is taking notes. Heavily distributed tunnel networks can absorb a massive amount of punishment, provided you keep pushing the absolute limits of geography. Which leaves global security with one serious question. Does Pickaxe Mountain mean Iran has finally found the depth that guarantees survival? Or does the next 15-year weapons program already have its target locked in?